Alright, welcome back to my YouTube channel, tutorials where mathematics literacy begins. Alright, we are still on Math 103 subsidiary mathematics, which is the elementary calculus. Now, this time around, we concentrating on the differentiation of the natural logarithmic functions. Differentiation of the natural logarithmic functions. How best can we differentiate the lane as in, the lane functions? It is not in, it is in, which is the lane function. So the natural log functions. How best can we differentiate that? So now let's see. Alright, so let's see. We have it as rule 1. If you want to differentiate with respect to x of length x, we have it as 1 onwards x, that's 1 over x, which means that you take 1 over the expression inside the brackets, which is x. Now, rule 2. If g of x is differentiable, which means that if it is possible that we can differentiate g of x at x, which means with respect to x, then d dx of ln g of x is equal to, we take 1 over the g of x times differentiate the expression inside, or differentiate the function g of x inside the brackets. So we get g prime with respect to x. So now it becomes d dx of ln g of x, which must be equal to, we have multiplication of fractions. So we multiply the numerators, we multiply the denominators. Don't forget, this one is divided by what? 1. So we get g prime of x divided by g of x. So now let's start with our first example. We are solving 5 examples. So let's start with our first example and let's see. Alright, so let's see. Find dy dx if y equals length of what? Sine x. So how do we differentiate that? So we have y being equal to length of sine x. So we have this. How do we differentiate this function here? So now, don't forget, if you want to differentiate the natural logarithmic of functions, we said we take, so which is y prime, we take 1 over the function here, right? So that's sine x, right? Then times, we differentiate with respect to x of the expression sine x here. Right? So I get y prime equals 1 over sine x times, when differentiate sine x, don't forget that we get cos x. So now with this, we have y prime equals, this one is over 1. We multiply the numerators and the denominator. So we get cos x divided by sine x. Now, don't forget this. Alright, so let's see. Y prime equals what? Cos x over sine x. Now, you remember the identity for tan x. The identity for tan x is what? Sine x over what? Cos x. Now, so what is the identity for cos x over sine x? Which means that is a complement or the complementary of tan x. And the complementary of tan x is what? Cot x, right? So cot x. So cot x is what? Cos x over sine x. So I can say that this guy is the same thing as cot x. So now I can say that therefore our y prime of x is equal to cot x. Very, very simple. Cot x. Let's move on to our next example. Example 2. Alright, so let's see. Y equals sine x squared plus 1 ln x plus ln 4x cubed plus 3. How best can we differentiate these guys? Now we have sine x squared plus 1 multiplying the x. Don't forget, we have x here. X x here. So then that means they are all function of what? Y in terms of what? X. They are all in terms of x, right? So we can apply the product rule because they are multiplying. Now this one is in 4x cubed plus 3. So how best can we do? So we apply the product rule. This one is u, then this one is what? V. Don't forget. So I have my y prime, which must be equal to, we hold u constant, which means sine what? X squared plus 1. Then times we differentiate v with respect to x. How do we differentiate then x? It will be 1 over x, right? Don't forget. If you want to differentiate then x, you get 1 over what? X. Then plus, not this plus our product rule, plus, there's a plus inside, so plus, we hold what? Then x, that's very constant, then x constant, then times, we differentiate sine x squared plus 1. Now, if you are differentiating sine x squared plus 1, when you differentiate sine x squared plus 1, you get cos x squared plus 1. Then times the derivative of the expression inside the bracket. So with the derivative of the expression inside the bracket, we have what? 2x. Right. So we have 2x here. So now my y prime must be equal to, sorry, we've forgotten plus ln that. So now we are done with this, which is the product rule. We've applied the product rule on this function here. Then plus, how do we differentiate ln 4x cubed plus 3? It is 1 over 4x cubed plus 3. So we said that if the function here is differentiable, then we get 1 over what? The differential of the expression inside. So now, so times, we differentiate. 3 drops times 4, we get what? 12x, then we subtract 1 from the total power. So we get 2. Then plus 3, differentiate it, we get 7. So now my y prime can be written as sine x squared plus 1 times 1 over x. We get sine x squared plus 1 all over x. Then x is multiplying that. So we can get, let's see how best we can solve this. So y prime equals sine x squared plus 1 over x. Don't forget multiplication of fractions, then plus 9 ln x times this guys. So we get plus, you can see that 2x, we can get ln x, then cos x squared plus 1. Right. Then plus, don't forget 12x squared times that, we get 12x squared all over what? 4x cubed plus 3. So this is our differentiation with respect to what? X. So we get y prime equals to sine x squared plus 1 over x plus 2x ln x cos x squared plus 1 plus 12x squared over 4x cubed plus 3. That's how we differentiate that. So let's see our third example. All right, so let's see. Find the y over the x if y equals cos ln x. So I have my y equals cos of ln x. So we have this. Right. So I have the y over the x, which must be equal to, now, if we differentiate cos ln x, we get what? Minus sine ln x times differentiate the function inside, which is ln x. So dx of ln x. So I have dy over dx, which must be equal to negative sine ln x times, when differentiate ln x, don't forget we get 1 over x. So now I have my dy over dx, which must be equal to multiplication of fraction, numerators, denominators. So you get negative sine ln x divided by very simple and very, very trivial as well. So kindly watch it carefully. So now let's see this question. Find y prime if y equals ln of ln 2x plus 1. Let's see how best you can solve this question. Very fantastic. All right, so let's see. I have y equals ln of 2x plus 1. So now, dy over dx must be equal to, how do we differentiate length functions? It will be 1 over the expression inside the bracket, or the function, which is what? Length of 2x plus 1, right? Then times, we differentiate that, right? So we differentiate, get dx of what? Ln 2x plus 1. Right. So I have dy over dx, which must be equal to 1 over ln